Hello everyone, today I'm going to be going over the first 3 questions of the Advanced Higher Chemistry 2014 past paper. On to the first one. The quantum number which specifies the shape of an orbital is and we have the 4 quantum numbers specified. The first one is the principal quantum number, which is what energy level does the electron occupy. Then we have angular momentum quantum number, which is the one that determines its shape. It goes from 0 to -1. And as you can see here, an angular momentum number of 0 corresponds to an S subshell, 1 corresponds to a P subshell, 2 corresponds to D, and 3 corresponds to F. The magnetic quantum number goes from -L to +L, 0 included, and specifies the orientation of an orbital within a subshell. For example, the 3 p orbitals here would have different magnetic quantum numbers because they have different orientations. Now, the spin is the intrinsic spin of an electron and can only be positive or -1/2. Together with the other 3 quantum numbers, it ensures that no 2 electrons in an atom have the same set of 4 quantum numbers, which would be impossible because of Pauli's exclusion principle. Therefore, the answer here is B, because that is the quantum number that determines shape. On to the second one. Element number 104 in the periodic table is, and we have the 4 blocks. The S block is these 2 groups. The P block is this right hand section over here. The F block is the lanthanides and actinides, and this is the D block in the middle. Now, if we see here, 104 is Rutherfordium, which is in the D block, and therefore the answer here is C. Now, question 3. Which of the following statements is incorrect about electronic configurations of all first-row transition metal atoms in their ground states? We have 4 options. First, the 5 3d orbitals are degenerate. This is true because they are equal in energy, which is what degenerate means. B, they all have at least 1 electron in the 4s orbital. That is also true. You can check it for yourself. For D, when transitional metal atoms form ions, the 4s electrons are lost first. This is true because, as you can see in this diagram, the 4s, the subshell fills before the 4s fills before 3d, and 4s is also removed before 3d. Now, for C, it's mostly true for the transition metal atoms in the first row, but there are 2 notable exemptions, which are chromium and copper. And this is because of the extra stability of the half and fully filled 3d subshells respectively. This is an exemption to the Aufbau principle, and Aufbau in German means building up. As you can see, these 3d subshells for chromium is just 5 parallel spins, and for copper it's just fully filled subshells. So I hope you enjoyed this video. I'll publish more videos on this past paper and other future past papers. So if you're interested in that, please subscribe. Thank you for watching. Have a good day.